Hello guys, welcome back for another question from the chapter integral functions, and let us see what does our question say. So we have to find the integration of a function, and the function looks like cos x minus sin x upon 1 plus sin 2x dx. So this question is pretty straightforward. We can see that 1 can be written as sin square x plus cos square x, and sin 2x can be written as 2 sin x cos x, and we add these two terms, we get sin x plus cos x raised to the power 2. I think that is pretty easy, that is pretty straightforward till now. Now we can see that the denominator or the numerator, any one part of them, is the direct differential of the another. For in this case, the numerator is the direct differential of the denominator. So now let us see. 1 plus 2 sin, this is a mistake, this must be sin 2x, correct it over here. So 1 plus sin 2x can be written as, 1 is written as sin square x plus cos square x, and sin 2x is written as 2 sin x cos x from the trigonometric identity. So that makes it sin x plus cos x raised to the power 2. Now what? Now we assume sin x plus cos x is equal to t, and we differentiate it on the both sides with respect to x. So differentiation of sin x, cos x, differentiation of cos x minus sin x, dx is equal to dt. So now what we do? We replace sin x plus cos x as t, and the above part cos x minus sin x dx can be written as dt. So finally we get our integrand as integration of dt upon t square. So now moving to the next slide. Just wait a sec. Okay. Now this integration is pretty easy. Integration of x raised to the power n with respect to x is x raised to the power n plus 1 upon n plus 1. So here n is equal to minus 2. So n plus 1 is equal to minus 1. So that is what we are getting over here. But our answer is in the terms of t, but our question was in terms of x. So we have to backtrack the value of t into x. So finally we get minus 1 upon sin x plus cos x plus c as a final answer. So that is it. I hope you all got it. Thank you and have a nice day.